All right, so now that we've looked at example number 1 here, we're going to just take a look at a little bit about that. Okay, the slope of the line that we found in example number 1, now mine's not completed because I've done it on a different page, but that's okay. The slope of the line will represent what's called the rate of change. So how much is it changing over a certain amount of time? And it's the rate of change in the graph. In the case above, okay, the case that we went through there, it's going to represent the cost per minute. And I'm just going to abbreviate it. We can also think of that as minute. Okay. It's the cost per minute. So how much does it cost for every minute that you use your phone? Okay, again, it's a cell phone plan. The slope represents how much the linear function is rising or falling compared to the horizontal change. So in the case above here, we were talking about how much more are you paying for every single minute that you're using. Minutes are on the horizontal, and then our cost goes up based on the number of minutes. Slopes can represent the y per x, okay, or cost per minute, or miles per hour, or something else that we could always put in there. They're going to represent the y per x, so we can always think of that. In this case up here, we had minutes and cost, so it's cost per minute, okay, or minutes above 300. So examples that I just kind of mentioned there, we could talk about kilometers per hour, or dollars per minute, or something like meters per second, etc., 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 as there's a whole bunch of different options that we could use when we talk about rate of change. And we'll go through some this year, and then again next year in grade 11 you'll see a whole bunch more examples of rate of change. Now in the case above, the y-intercept represented the base cost, or what we might consider as the initial cost of the graph. The y-intercept is the place where the graph often starts, or the value when the x variable is equal to 0. So we could think of it as either where it starts, or when the x value is equal to 0, which tends to be often where a graph starts. Once a formula has been made for a linear function, any point along the graph can be determined. Okay, so we can find any single point along the graph once we know the equation for that graph. What we do is we place the given information into the formula in place of the variable. Then we solve for the other variable. So if we know what x is, we can find y. If we know what y is, we can find x. This is a little bit what we did in the beginning of this unit. We were taking a look at, initially, linear functions. Okay? So these are all things that we can do based on the function we have and the information that we know. Please look at the next video for the next example.